Today we're going to learn about linear correlation. Correlation is how we describe patterns that occur in data. We talked about patterns that occur in data yesterday. We're going to discuss linear correlation, which talks about when data looks roughly like it's in the shape of a line, like this graph and this graph, how they look roughly in the shape of the line. But you can have different types of linear correlation. We're also going to talk about the direction of the correlation, so how the variables affect each other. This graph is a positive correlation. The graph goes up, well, the data go up as you read from left to right. So it has a positive slope. Positive correlation means the line has a positive slope and it goes up as you read from left to right. The variables get bigger and smaller together. So as x goes up, y goes up. As x goes down, y goes down, and x and y do the same thing. Negative correlation means that as one variable gets bigger, the other one gets smaller. So it has a negative slope, so it goes down as you read from left to right, and x and y do the opposite of each other. And no correlation means that there is no pattern. If you were to draw a line, that line would be flat. So it's a big ball, it's a big jumbled mess, a big fat flat blob. And you could say, like, even if it looks like the data is very, like there's a general trend that you can draw a line there, it doesn't look like the x variable affects the y variable very much. Like the y variable just stayed in the same spot the whole time. So that's why we say it has no correlation, because it didn't matter what x was, y was exactly the same the whole time. So now we're going to classify these. In this set of data, if I were to draw a point in the middle of my data, a line in the middle of my data, then I would say it's about there, and it has a positive slope, so this has a positive correlation. It goes up as you read from left to right. Here's this one. I don't know where I would draw a line because you could kind of go wherever, and it doesn't look like it goes even roughly in a line, so this has no correlation. All right, if I were to draw a line through the middle of all of this data, then it goes down as you read from left to right. So this has a negative correlation. And then this one is flat, so it has no correlation. I find it interesting that no correlation could look totally different. Like B and D are totally different things. But all we need to know is that they didn't generally go up or generally go down, so it's no correlation. Let's think about some examples where we just have to think about what we know about that type of thing and think about whether or not it affects the other. So the hours a person has been working and the amount they are paid. As hours go up, pay goes up. So remember from our definitions, in positive correlation, x and y do the same thing, and negative, they do opposite things. So because they're doing the same thing, we're going to say this has positive correlation. The age of a cell phone and its value. As your age goes up, as the cell phone gets older, then its value, it's going to decrease in value. So this is a negative correlation because they're doing opposite things. Then on this one, the last 4 digits of your phone number and your score your last math test. So as your phone number digits go up, I don't even keep track of this, does your score go up or down? And you may think that suddenly there's something in the phone numbers, they know something about us, but think about it. If you were to get a new phone number today, would it affect your next math test? Probably not. So this is no correlation. And let's look at our last starred example, your age and the color of your hair. So I think your age does affect the color of your hair because the color of your hair is gray. However, we can't graph these, and you can't say that the color of your hair is going up, right? So this is numerical data, your age, but the color of your hair is something called categorical data. It comes in categories, different types. So we can't actually graph this. There's probably a relationship, but because we can't graph it on a scatter plot, we're going to say no correlation. Now we have a few more questions just talking about this scatter plot over here to the right. Mr. Bentley was wondering if there was a relationship between the number of absences a student has and their grade percentage at the end of the quarter. In order to analyze this relationship, he created that scatter plot. So what does this circled data point mean? Now each data point is going to mean a point of data. In this one, it's talking about the number of absences a student has. So each data point is a student. So that is a student who has, and then we go down to the x-axis and we find they have 12 absences. And go over to the y-axis. It's between 40 and 50. So I'd say this is 45, and that's their grade. And a 45% as their grade. So it's important to note that every single point is important. It represents a piece of data. In this case, it represents a student, but it could represent a person, a state, a country, a different day. You just have to read the question to see what they're talking about. For part B, give a possible explanation for the cluster of points in the upper right corner of the graph. So let's go find it. Cluster means a group, and it's a group that's close together. So here we have a group, and so that means that there's a lot of students in that little small area, a lot of students between 0 and 4 absences and between 75 and 90%. So we'd say a lot of students miss only 0 to 4 days and have a pretty good grade. Do there appear to be any outliers in the data? If yes, what are they? Provide an explanation. So outlier sounds like exactly what it is. It lies outside of the data, but what's more important is that it lies outside of the trend. So on our graph, it looks like the general trend is going down. If I were to draw a line through the middle, it looks like that. Now, a lot of students will pick out the points that are most isolated as their outliers. So that one, and that one. But these ones over here, I probably wouldn't call outliers because they still follow the trend of being high number absences and low number grade. The one I would call an outlier is that one right there. The 220. So they have 2 absences and their grade is only at 20%. So why does a person with that few absences have that low of a grade? Well, maybe they're struggling in school. Maybe they have a hard time getting sleep, so they fall asleep in class. Maybe they missed a lot of school in a previous year, so they don't remember as much, so their grade is low. It could be a lot of different things. Now, you can just think of a scenario that works to explain that, but we don't actually know because we just have the numbers. Does the scatter plot suggest a relationship between absences and grade? Yes, we already discussed that as absences go up, grade goes down. So that means it has a negative correlation. I would make sure if you answer questions like this to take note of your variables. There is a negative correlation and what were our variables? Absences and grade. So between the number of absences and the grade received. Okay, that's it. Good luck.